Hello and welcome to this training on using render passes in Maya, presented by Digital Tutors, an Autodesk authorized publisher. My name's Kyle, and I'll be guiding you through the process of using the new multi-pass rendering system introduced in Maya 2009, which we can now use to render our scenes out in multiple passes at speeds much faster than using traditional render layers. Now, with any type of rendering-intensive project, keeping the render times down to a minimum is a very high priority. And with the new render pass system, we now have the capability to output multiple render passes in a time normally taken to just render one single image. And as we'll see during the course of this training, the render passes gives us a very high degree of control over our final images that really was just not possible with previous versions of Maya. So we'll begin our training with an overview of the render pass system and how it can be used in conjunction with render layers. We'll also look at how we can isolate objects onto individual passes for easy compositing, and we'll explore how we can set up our own custom rendering buffers to output our own render passes. And we'll also see how Toxic can be used to completely automate the process of reassembling our passes back into a final image. So we have a lot of material to talk about over the course of the next couple of hours, so in the next lesson, we'll begin by discussing some of the changes that have been made to the render settings starting in Maya 2009. In the first lesson of our training, we're going to take a look at some of the changes that have been made to the render setup panel starting in Maya 2009. Alright, so before we actually begin our discussion on these render passes, I just want to take a few minutes to kind of make you aware of some of the changes that have been made to the render setup now starting in Maya 2009. So let's take a look at this render setup. Now, one thing that's going to be important to know is that for the duration of this training, we're actually going to be relying on MentalRay, right? Because MentalRay contains the actual pass information that we're going to be relying on. Now, once you switch to MentalRay, you will notice that there are a few changes. Number one, you'll see that we can actually switch our render layers right here from within the render setup, and we can actually do this with any render engine. But the main thing about MentalRay is you'll notice that now everything has been split up a lot compared to how it was in previous versions. So now we have this common panel, which contains all the information about the image file format, the image name, extension, the actual start and end frames, any renderable cameras that we have in the scene, image dimensions, things like that. Alright, now the passes tab actually contains all the render pass information. We'll be spending actually a lot of our training in this area, so we'll definitely be exploring this area. Now within the Features tab, we have kind of a combination of some features that have always been available in MentalRay, and actually a few new features that, again, have really always kind of been here, but have just recently been now kind of uncovered for general usage here in Maya 2009. So things like the render mode, we can now choose between a normal render or whether we want to just render out final gather maps if we're rendering out these out to a separate map. We can do the same for light and shadow maps as well. Again, these settings have really always been here in earlier versions of Maya. It's just now that they've been exposed so that they're really easy to get to. And we can also choose whether or not we're going to use the scanline, rasterizer, or the ray trace renderer. Alright, in addition, we can also turn on and off very quickly certain things like global illumination, caustics, or final gathering. Now, in the past, it was sometimes easy to kind of get confused or sometimes turn things on that shouldn't be turned on whenever activating combinations of these secondary effects. But now in Maya 2009, these have actually got a little bit of logic built into them now. So, for example, if I were to turn on something like global illumination, now we have access to be able to engage or enable these importons. So, otherwise, if my GI is turned off, I don't have the capability to turn this on. Also, things like irradiance particles, which is a new feature in Maya 2009. Right now, the irradiance particles are not compatible with final gathering, so as long as final gathering is turned on, irradiance particles cannot be enabled, and you can see they're grayed out. So once I disable final gather, now I have the ability to turn these on. So it really is a much more straightforward way of just making sure you don't have things turned on that are going to conflict with each other. Alright, now over here in the Quality tab, we have these quality presets that we've always had, so this is where we can choose between our different draft, preview, production, things like that. And we can also change our ray trace, our scanline quality, things like that. Found a little bit further down. All right. And then over here, we now have a whole separate tab specifically dedicated to indirect lighting. So GI, global illumination. We also have caustics, the photons, importons, final gathering, and irradiance particles, as well as ambient occlusion now that's built right into the render. And then finally over here, we have the options. This is where we can do things like diagnostics. We can override things like GI settings and displacement approximations. All those can now be found inside this Options tab. All right, so just a quick little overview just so that there's no surprises as we get a little bit further in this training. And really, for the most part, we're not going to be worrying about anything that's in these other tabs. Really, we're going to be focusing our attention on the things that are contained within this Passes tab. All right, so that's a look at some of the new render settings reorganization that's happened now in Maya 2009. So in our next lesson, we're going to go ahead and continue on by talking about some of the render layers and render layer overrides. All right, so before we begin our discussion on render passes in Maya, let's actually take a few minutes to explore the render layers. All right, now the render layers are something that have actually existed in Maya for quite some time now. And in the past, we could always kind of use the term render passes and render layers really kind of interchangeably. But now, in Maya 2009, there's a new dedicated render passes system. So it's going to be important for us to understand what the difference is between a render layer and a render pass. All right, now if you're already familiar with the render layers, you're welcome to go ahead and skip over this lesson and proceed over to the lesson where we deal with render passes. But in the past, what we used to have to do if we wanted to take this image and actually split it up into things like a specular pass or a shadow pass or a diffuse pass, we would actually have to make a new render layer. And during render time, the renderer would go through and actually render each layer one by one. Now, as we'll see, this render passes system that's now been introduced in Maya 2009 really is not intended to be a complete replacement for the render layers. Instead, it can really just kind of be used to augment and help you do things that really would be difficult to do with the render layers by themselves. So there are going to be some situations where we will still find ourselves using these different render layers. All right, now to access the render layers, they can be found inside the channel box over here. Right now we have display, render layers, and now in Maya 2009 we have animation layers as well. Now what we're going to do is click on the animation layers, or rather the render layers, and what we can do is actually make a new render layer by either just making a blank one, or we can make a new render layer out of any objects that we have selected. So what we would try to do is, let's first maximize this, and we could open up something like the outliner and take any lights and any objects that we wanted to add to a new render layer, and with those selected, we'll create a new render layer from the selected objects. Right, you can see now they've been added to this new render layer. Now we can actually kind of selectively add things that we want, so maybe we just want a render layer with the light and maybe a vase. Add a new render layer, and now you can see that only these objects have been added to that render layer, and when I hit render, only these objects will be rendered. Right, so this is how we used to have to go through the process of actually breaking our images apart into separate individual pieces. All right, and as we'll see with the render passes, we actually have a little bit different method of doing that. All right, so we have this render layer set up now. Now, with this render layer, we can actually do some really neat things. Things like if we were to take, let's say maybe this vase, and let's say we wanted it to contribute shadows to the scene, and maybe even some indirect light that is going to bounce off of it, but we don't want this vase itself to be rendered. What we can do is, in the render stats for this object, we can turn off its primary visibility. Now you'll notice when I turn off the primary visibility that it turns sort of this orange color. Now this is done only if I have some kind of an alternative render layer selected, something other than my master layer. Now what this orange color means is that we have currently enabled something called a layer override. All right? Now, in a second we'll see how these layer overrides can become very, very important and very, very useful. So what we should see now with this lamp's, or rather this vase's primary visibility turned off, is when I hit render. And now you can see that this vase is really still being calculated in the scene as far as its shadows and any indirect light that may be bouncing off of it, but as far as its primary visibility, its visibility to the camera, it's now not visible. Alright? So lots and lots of power that can be found within these different layer overrides. Now, again, this can be done on a per object basis, on a per layer basis. So we can have this object visible on certain render layers and have it invisible on other render layers that we have it assigned to. Now, another thing that we have the ability to do when it comes to using these render layers is we can actually create material overrides. So, for example, if I wanted to make something like an ambient occlusion pass, well, what we could do is take a look inside these metal ray nodes, and let's drop in this MIB ambient occlusion. This is a texture, and what we can do is loop this through a Maya node, something like a surface shader. Connect this over to the color. Alright, and let's just set this max distance to something a little bit lower, something like 20. Now, rather than actually taking this shader and assigning it to all the objects that we currently have in our scene, what that would do is actually override all the materials that we currently have on here. But what we can do instead is take this and assign this as a material override just for this layer. Now, in Maya 2009, that's done a little bit differently than what we were able to do in previous versions. So now, all we need to do is just right-click on this shader itself and assign that as a material override for this current rendered layer. And you'll notice in my case, this scene has now turned completely black, but that's okay. That's actually just a result of the shader. And so whenever we hit render, now we should see this ambient occlusion that is been applied to all these different objects. Now let me set this back to a smooth shade, and you'll notice that once I go back to this master layer, all the materials are still retained as is. We've just assigned this material for this particular render layer. Now, another thing that we can do is that when it comes down to render time, if we were to render out this layer with this ambient occlusion material, we don't necessarily need things like the final gathering or some of these other effects that we have enabled. So what we can do is pretty much for any attribute anywhere in Maya, we can right-click on it and create a layer override. Right? You'll see once this turns orange, that's now been overridden. And so now we can turn off final gathering for this particular render layer. But once we go back to the master layer, it's now active again. Right? So we can go in and selectively turn off and turn on all these different features on a per render layer basis. So with that functionality in mind, you can see where we can really still use render layers for a lot of things within Maya. And again, now that we hit render, we can see our ambient occlusion result. Alright, so that's a look at some of these render layers and these layer overrides that could be assigned on a per layer basis for really just about anything in our scene. So now that we have an understanding of what these render layers are and some of the functionality that they provide, we can now take a look at what the render passes can let us do now starting in Maya 2009. Alright, so now that we've had a chance to talk about render layers in Maya, now let's talk about how those render layers are different from render passes. Alright, so previously, whenever using Maya, we would use render layers as a way of separating out our image into multiple pieces. Alright, so rather than just taking our final rendered image, or our beauty pass, and then using that as our final result, we could always use render layers to separate out things like the diffuse color, and then make a separate reflection, separate refraction, separate specular, and so on and so forth, and then we could composite those all back together to make our final image. And that obviously gives you a much higher level of control, because now you can tweak and tune each little component of the final image. All right, now the downfall of that was that we would have to make separate render layers for each of these components. So we'd need to make a new render layer for the diffuse color and assign its own special material override for that layer. and then we'd have to go in and make a new layer override or a new layer for the reflection, and again give it its own special material override, and a new layer for specular, and a new layer for shadows, and so on and so forth. And then at render time, it would go through and actually render each layer one by one by one. So the downfall of using these render layers is the fact that as you add more layers, you add more render time, again because the render has to go in and render each layer one by one. Now with the render passes, it really is kind of able to give us the same effect as far as being able to render out these different components. But the main beauty of using these render passes is the fact that they add almost no render time to our final rendered image, right? And the reason is because that the way that these render passes and the way that render layers work is fundamentally very, very different. All right? Now, with render passes, what this does is it utilizes a feature of MentalRay called frame buffers. And really what happens behind the scenes is whenever we hit render and we get our final beauty image, behind the scenes there's all these other things that have been calculated. So it'll calculate the diffuse color, and then calculate any direct lighting, and then any indirect lighting, and then reflections and refractions and specular and shadow and so on and so forth until we get our final image. Now what frame buffers will let us do, and what these render passes will let us do, is basically take all of this information that's already been calculated and then just simply writes that out into individual images. So that's how we can use these render passes to get all this stuff separated out into its individual components without really adding any extra render time and without having to set up any new render layers to make this process happen. All right, now as I mentioned in a previous lesson, these render passes really should not be viewed as a total replacement for the render layers, because as we've seen in the previous lesson, render layers do have functionality like layer overrides, material overrides, things that the render passes don't have the ability to do. So rather than thinking of render passes as a total replacement for render layers, really just try to think of them as a new feature that can be used to really push the ability of render layers a lot further. And also, you don't necessarily have to rely on render layers as much as we previously did. Alright, now to actually get these passes set up and assigned within our scene, it's really a pretty straightforward process. Again, we do need to make sure that we're using MentalRay because these frame buffers that we're going to be using, these passes, are a feature of MentalRay. So a lot of times you may actually hear me refer to render passes and render buffers as kind of the same thing. So if I use the term render buffers, I am talking about these render passes. Alright? Now, whenever you open this render settings, you may see these buttons are actually a little bit hidden. Right? You may see something like this. So if you don't see any of these buttons on the side, just take your render settings window and just try to pull this over until you see these icons revealed. So this is where we can actually add our render passes. So we'll create a new pass. You can see that we actually have a lot of these pre-built passes to be able to choose from. And the passes that you actually use are really kind of dependent on your particular needs. You don't necessarily need to output all of these passes to get all of this different color information selected out. So for example, if we wanted to get, let's say, diffuse color, right? We have really three options to be able to do this. We could use a diffuse material color, which would be just flat shading information, no lighting, no shadows whatsoever. We could do diffuse without shadows, which will give us the lighting information and specular highlights and stuff like that, but without any shadows actually rendered out, or just diffuse, which will include the shadows in that. So depending on the level of control you want over your diffuse element, you can choose between any of these different render passes. And same goes for some of these other ones. Right? So for example, like specular with shadow, or just specular. Right? And another thing that does sometimes control the actual passes that you need is somewhat going to depend on the actual material that you use. So as we'll see a little bit later, some of these MentalRay materials are actually sort of limited as far as which particular passes or which buffers can be written out. So for the moment, at least in this earlier part of the training, I'm using entirely Maya materials. So with these Maya materials, we can use pretty much any of these different buffers. So to write these buffers out, we'll just simply choose which ones we want. So let's add a beauty, and we can actually add multiple buffers if we just hold our control key and click and add. So let's add something like diffuse. And we do have something that is reflective in this scene, so we'll need to make sure that we add a little bit of reflectivity. We've got a little bit of specular on this, so let's add some specularity. Right, and we can always go ahead and write this out as a separate shadow pass if we want to, just to kind of see what that looks like. Alright, so once we have this, let's also go ahead and write out an indirect, which will cast and sort of calculate all the final gather and global illumination information. Once that's done, we can create and close. Alright, so now we have these different passes that are available to us. Now, right now, if we were to hit render, we would not be able to utilize any of these passes because right now, what we have up here in this scene passes area are just the passes that have been created for this particular scene. Even though they've been created, they're not going to be used. At least not until we take these and associate them with a particular pass. Alright, so we can actually build these passes on a per layer basis. So whenever it talks about this associated pass, what this will do is now use these particular passes whenever this particular render layer is utilized. So immediately you can kind of start to see the level of control that we gain. Not only do we have the ability to put out these different passes, but now we can actually control particular passes that are going to be output on individual render layers. Alright? So once we have this set up, what we should be able to do is now go up to the render and batch render this out. Alright, and so now you can see my render is done, rendering completed. And really, again, very little impact on your total render time. The beauty of these render passes, as I mentioned, is the fact that we only have to go through this rendering process once. And during this render process, MentalRay will automatically write out these different images. So if you take a look inside the images directory of our current project, you can see that MentalRay has automatically made a folder for each of these different passes that we created. Right, so let me just resize this a little bit. And if I take a look inside any of these different folders, you can see here is the actual image file, and that is being determined by the scene setup that we have over here in the Render tab or over in the Common tab. Alright, so once we have this, now we can actually look at these different images. Alright, so here's the indirect lighting contribution. Alright, and we also have the reflection. Again, now all of these different elements have been separated out, and we have full control over these whenever it comes to time to actually recomposite all this information back together. Alright, so right now, again, this is all writing out into separate folders. So what we can actually do is use these different render setup options to actually control how this information is going to be written out. We'll take a look at the process of controlling this in the next lesson. Alright, in the previous lesson we looked at really what a render pass is and how it works within Maya. So now that we've seen basically just what these render passes are, now let's take some time to explore some of the settings that are found within this render passes panel. Alright, so let's go ahead and go up to the render setup, and let's go back to this passes tab. Alright, so in our previous lesson we were able to see basically just how you can create a new render pass, but as you can see there are some other options down here as well. So whenever we create a new render pass, we can select these and add these as we need. So let's say beauty, diffuse, maybe indirect, and let's also add maybe a shadow and maybe a reflection as well. Now, whenever we add these, we can just simply create and close just to drop these in, but you'll see that we can also add a pass prefix or a pass suffix to this as well. So, for example, if I needed to create multiple passes, let's say passes that were isolated to individual objects, we could create our own pass prefix to kind of determine what these images hold whenever it comes time to render these out. So for example, let's say maybe reflective vase, something like that. I'll put something like an underscore just so that we can actually get some kind of a separation between that and this pass name that's going to be added onto that. And whenever we create, you can see now these new passes have been added that have maybe some kind of a little bit of descriptive item in front of them. Right? And same goes for adding something as a suffix. Right? We can add something a little bit more descriptive. Create and close. And there we go. All right. Now, just like what we talked about in our previous lesson, we have these passes that have now been added into the scene. All right, so they exist at a scene level, but they're not actually being utilized at render time. Right? In order to get one of these to be used, we actually have to associate it to a current render layer. All right, so if I were to take, let's say, some of these items down here, let's say this shadow option, and add this to my current render layer. Now, whenever this render layer is rendered out, it'll render out these particular passes. Right now, I could actually make my own new render layer and assign a whole new set of passes to those. So let's say I select all my objects, make a new render layer. All right, and now when I select this render layer, automatically you'll notice that this passes panel kind of reconfigures itself. Now we're using layer 1, which no passes have been associated to it. So with this, we could take some of these other passes that have this reflective vase description in front, add this in, and now those are going to be used when it comes time to actually render the scene when this render layer is active. Right. So now you can see as I jump back and forth between these layers, we have completely separate passes that are going to be rendered out for each layer. Now, one thing that's important to realize is that this particular pass name that we've defined, this reflective vase underscore diffuse, whenever it comes time to render, Maya is actually going to render out an image with this particular name. Right? So that's something that's very, very important to remember, especially when it comes time to using something like a contribution map, which we'll talk about in the next lesson. But for now, it's just very, very important to keep in mind that whenever it renders out, you will actually wind up with an image that's called reflective vase diffuse. Right? Now, if we have any of these particular passes, then let's say maybe they've been added to this render layer or associated to this render layer, and now maybe we want to remove them, or we don't want to use them anymore. All you need to do is select any number of these passes, and then just click on this button right here to deassociate it from this particular pass, and now it's been moved back up here to this scene level render passes. Okay? Now, whenever using a lot of these different render layers, sometimes it could be kind of a pain to come in and manually select each one by one and assign them to each particular render layer. Alright, so what we can actually do to kind of aid this process is create something called a pass set. Alright, now this is found at this button right underneath this button where we create the new render passes themselves. So just for demonstration's sake, let's take all these associated passes from both of these render layers, and we'll just deassociate these for now. Now what we can do is create something called a pass set to just kind of aid this process. So let's take this different beauty pass here. Let's actually take all these things that have this vase reflective suffix at the end, and with all these selected, we'll make a new pass set. Right? You can see now this created this new pass set. So now, rather than having to select each and every one of these and associate those to a pass, what I can now do is just select this pass set, associate it, and now it'll automatically take any of these render passes that are contained within this pass set, and now those have been associated to this particular layer. Right? So it really does the exact same thing as taking all these different objects and associating them. Just kind of think of this as a containing folder now. All right. And again, this can be associated and de-associated with these different render layers. Now, if you want to see the different passes that are contained within this render pass set, we can use this actual relationship editor. So if I open that up, we can now see this render pass set 1, and we can see all the different passes that are contained within that. All right, now at the moment, none of these different render passes are actually highlighted, meaning they are not part of this render pass set. So we can very quickly and easily add these. Just click and add. Take this reflective vase. Any of these that have this reflective vase prefix. And now once those are selected, those are now considered part of this render pass set. Alright, so we can actually make multiple render pass sets if we want to. So we'll make a new render pass set. Again, go back to our pass set editor. And now we can take any of these other passes and just click on those to make those part of this render pass set. And again, now you can see as I click back and forth, we have render pass set 1 and render pass set 2. And we can rename these. Something like reflective vase set. And something else like passes set. Right, so you can see how you can very quickly start to differentiate between these two. All right. Just below that, you have a couple of other buttons. One is this Edit Selected Render Pass. And so what that will do is any of these passes that we have selected, we can just click on this and take a look at the attributes for this particular render pass over in the Attribute Editor. And we can get the exact same effect if we just double-click on any of these passes. We can actually see their different attributes there. Now, just below that, we have the ability to actually delete any render passes or any render pass sets that we have currently selected. So now if we decide, rather than maybe not necessarily needing them on this particular render layer, now we don't need them in the scene at all, or maybe we accidentally added something that we don't need. So you can just select this, and with those selected, delete those current passes. Alright, so that's pretty much a look at how we can start to add these different passes into our scene, associate them with a current render layer, as well as start to take some of these different passes and merge them together into these render pass sets to very quickly and easily just associate one particular object or one node to a pass rather than having to associate a whole bunch of different objects. Alright, so in our next lesson we'll take a look at how we can start to organize the way that our images are going to be rendered out through this pass system. In this lesson, we're going to take a look at the render tokens that are available within the Maya render system. Now what this will do is give us a finer level of control over the output directory of our rendered images. Alright, now in this scene what I have set up is actually two render layers, our master layer and a second layer that I've set up just called render layer 2. Alright, so this is an example of where we might be able to use two different render layers to actually split our image apart. So in this render layer 2, we've got just our main pieces of geometry, and in the master layer we have everything. Now in this render passes, for the master layer we've made a set of passes for ambient, beauty, diffuse, and so on and so forth. And we've also taken those same passes and associated those to this other render layer as well. So what we'll get is a whole series of passes, a beauty pass, diffuse, specular, reflection, all of these for each of these different render layers. Alright, so immediately you can start to see the power that you start to get when you combine these render passes together with the render layers. Alright, now whenever I render this out, we're going to wind up with a whole series of images. And remember, as I mentioned in one of the previous lessons, the actual names of these passes is actually going to represent the name of the image that's written out. So we're going to wind up with an image called ambient, and an image called beauty, and an image called diffuse, and so on and so forth. Now, if I were to just simply take this scene that we have right now and render it out, we're going to get a directory structure similar to this inside of our images directory. We're going to get one folder that is basically representative of the name of our render layer. Okay, so we have render layer 2 and the master layer. Now within each of these folders, it's actually created a new folder for each of these passes. All right, so again, this folder, you can see, is representative, or it's the same name as the different passes that we have named over here in Maya. Now within each of those, we have our actual file. Now this can start to be a problem because you'll notice that each file is named, let's say, lesson 05. In our case, it's just deriving the name from the actual Maya file. But you can see where this can get to be a problem because we have now a whole series of folders with an image inside of it, and each of these images is named exactly the same thing, even though the data that's contained in that image is completely unique. So for example, here's the reflection pass, and if we were to take it something like the diffuse pass, again, same exact file, but in the image itself it's totally different. So whenever we render these out, we'd probably want to make sure that the image inside is somewhat unique, or at least we could tell what is going to be contained in the image by looking at the image name. Now this can be done with a feature in MetalRay, or rather a feature in Maya, called the render tokens. Now this is going to be found over in the Common tab. This is the same area where we can actually define some kind of a file name, but within this we can actually add these render tokens if we right-click, things like the layer name, the camera name, the extension, things like that. Now, this is actually one of the features that have been available in Maya for quite some time now. But now with the addition of these render passes, this feature does start to become much more important as far as making sure that our files are organized correctly. So in our case, let's try to name something a little bit more descriptive. We'll call this render token test. Okay, now if I were to render this out, you can see what we would basically get. Our render layer name, and then the name of the pass, and then within that folder, we would have this file called render token test. All right, in our case, we can now change this file to anything we want. Let's say maybe a bitmap. So render token test. Now, rather than actually making a new folder with each render pass name in it, like a folder for beauty, a folder for ambient, so on and so forth, what we can do is just add a quick something like an underscore just to separate the name, and then we'll add this render token for render pass. So now, if you take a look at what we're going to get, we're going to have a folder for the actual render layer name, and now we're just going to get a file that is render token test underscore and then the name of that render pass. Alright, so let's give this a quick test. We'll render this out. And we should see now that the renders that come out are structured in a completely different directory. So if I take a look at the images directory that this was rendered out to, just like before, we have the master layer and the actual render layer 2. Again, that's being defined by this name. Now within that, now if you take a look at the images that are rendered out, we have this render token test and then the actual name of the pass that is rendered out. Alright? So very nice way of being able to organize this, and again, depending entirely on how we want to structure this, maybe instead of this render token test being part of the image name, maybe we actually want to make a folder called render token test. And then within this we can actually string together a couple of these render tokens. So let's right click and add a new render token for the render layer, and maybe separate that by an underscore. Alright, so now we should get something completely different. Now we should get a folder called render token test, and then within that we should have a series of images that correspond to the rendered layer name and the name of the render pass. Right, so let's test this out. Again, we'll batch render this. And now, once this is rendered out, we should get a totally new directory structure. Alright, so now, just like before, we have a folder that's now defined by our name. In this case, we named a folder called render token test, and now within that, we have these separate images. So here's our specular, shadow, diffuse, indirect, and so on and so forth for the master layer. And now the same for render layer 2. Right, so really this does give you a very, very high level of flexibility and a great level of control over the actual directory structures that your images are going to be rendered into. And again, because now with these render passes, we are rendering out so many images, the organization and the structuring of that does become very, very important. And the way that you actually choose to organize that is completely up to you. Alright, so that's a look at some of the things that we can control with these render tokens. In this lesson, we're going to take a look at how we can create and use contribution maps within the render pass system. Alright, so before the advent of the render pass system in previous versions of Maya, if we wanted to take different elements of our scene and actually separate them out, we would actually have to create a new render layer. Right, so for example, if I wanted this sphere to be isolated on its own when at render time, I would have to make a new render layer and assign this sphere to that particular render layer. Now, again, as we've discussed before, the disadvantage to that is that the render layer that this sphere is on is going to have to be rendered after the initial render happens. Right? So we introduce now 2 render cycles. Now, with the render passes system, we can actually isolate objects on an individual layer. Now this is done with something called a contribution map, right? And really you can just think of this as a way of isolating certain objects. So for example, if I had this sphere, right, and again, I want to be able to separate this out and have it isolated on its own, so I can maybe go in and post and maybe do some minor color correction or whatever the situation calls for. What we can do is create a contribution map by selecting this object, right-click on your render layer, and actually what I need to get to is a little bit out of the picture, so let me see if I can right-click on this, and what we can do is create a pass contribution map. And you can see we can either create an empty pass contribution map or make a new map and add whatever objects we currently have selected. So here we go, we can add a new contribution map. Now once we do this, you can see this little arrow that comes up to the side of our render layer, and we expand that, we can see this pass contribution map that was created. Alright, and I can rename this to something that is a little bit more definable or a little bit more readable. So let's say something like sphere contribution map. Oops, looks like I mislabeled that. There we go. And we can now make a second contribution map with these other objects assigned to it. So again, let's select these objects and just right-click, and let's add a new pass contribution map, and we'll create a new one and add selected objects. Alright, so again, we call this something a little bit more noticeable. Maybe something like environment contribution map. Alright, now once we have these contribution maps created, we can actually assign now a series of passes to each contribution map. So let's go back to the Pass tab. And just to make this a little bit easier to demonstrate, let's do something really simple like a beauty pass. Alright, now once we associate a particular pass with a render layer, we now have the added control of actually being able to associate a particular pass with now an individual contribution map on that layer. So you can see now this very deep level of control on a per pass basis. You can assign particular passes, or on a per layer basis, you can assign particular passes. And you can even assign passes on a per contribution map. Now, one thing that I alluded to in an earlier lesson that's very, very important to remember is that this beauty is actually the name of the image that's going to be output. Right? Now, if we have 2 different contribution maps, let's say we assign this beauty to it, what we're going to get is basically a cumulative effect. So each contribution map is going to write its information to this one particular image. So if we want to be able to separate this out, we have to make sure that we make a special pass for each contribution map. Alright, so let's take this and disassociate it. And let's add a second beauty pass instead. We can call this something like sphere. We'll create this, right, and we'll make another one for the environment. This time we'll create and close. So here's this beauty pass. We don't necessarily need that anymore. Right, so now we have a beauty pass for the environment and one for the sphere by itself. Alright, so here's the environment contribution map that we have selected. In our case, we'll select the beauty environment pass, assign that, and we'll do the same to the sphere contribution map. Assign the beauty pass for just the sphere. Alright, so now in our directory, in our output, we have a folder set up called contribution map renders, and within this we have the render layer and the render pass. Alright, although in this case, since we just have one render layer, we probably don't need that particular flag in there. So we should now just get an image for the render pass. So with that, we should get one image for beauty environment and any information that's written into it, and one image for beauty sphere. So let's see what we get now. Let's render this out. Alright, and once this is done rendering, we should see now we have a folder that we've defined. In our case, we named this contribution map renders. And within this, now we have an individual image for each one of these passes. You'll notice it also throws in this master beauty pass. And this is basically just the overall beauty pass of what we would get from the final render of this particular render layer. So if we take a look at the individual images, we have a beauty pass for the environment, right? So everything except this sphere. You'll notice this sphere where it should be, instead we just kind of get this little black area. This is actually completely normal. This is actually a function of the render passes. And if we take a look at the sphere itself, it's now isolated as well. Now the beauty of this is that we didn't have to burn up any additional render time. We just had to go through one render cycle in order to get these three images out. Now this dark spot that we see is what's referred to as a holdout, and we'll talk about this and some other advanced options a little bit later in this training kit. But this is actually completely normal, and this is actually one of the added benefits that we get from using these contribution maps as opposed to isolating our objects on individual render layers. And the beauty of that, or the benefit that we get from that, is that the objects that we have in each contribution map actually affect the other objects that are not included in it. So you'll see that even though this sphere is not included in this particular contribution map, we still have all of the features that it would normally have. So we still get shadows from this sphere, we still get indirect illumination that bounces off of this sphere, but we just don't get the sphere itself. And likewise, if we look at the sphere, you can see that we still get indirect illumination that bounces off the objects and bounces off the floor underneath it. But again, we don't have to worry about necessarily isolating that within the render itself. And if we were to isolate this on its own render layer, we would not get this kind of a result. Alright, so lots and lots of power that we can actually get from using these render passes assigned to each contribution map. And in this case, again, I just use a beauty pass, but you could actually go very deep into this and actually assign a specular pass, a diffuse pass, reflection, and all these other things for each contribution map. Alright, you just need to make sure that each of these passes is uniquely named. So for example, if you had a set of specular passes that you wanted to get out for this environment contribution map, you just want to make sure that the specular pass for this contribution map is named something unique from the specular pass in this contribution map, and that those are assigned accordingly. Alright, so in our next lesson we're going to talk about how we can use these contribution maps to actually attain a little bit deeper level of control as on our scene, that is, as far as lighting goes. Right, so we'll take a look at that in our next lesson. Alright, building upon what we talked about in the previous lesson, we'll now see how we can use contribution maps to actually isolate lighting on individual objects. Alright, so here's the scene that we're going to be working with. So let's go ahead and start by just taking these contribution maps that we built in the previous lesson, and let's just delete these contribution maps, since we're going to go ahead and actually rebuild these here in just a moment. Now to take a look at what we're going to be actually rendering out, let's just take a quick render. And you'll see in this image we actually have two different lights set up. One is a light that has a little bit more of a red color to it, and the other light is one that has a little bit more of a blue color to it. So a lot of times what you might want to do when it comes to actually compositing some of these layers back together, one thing that is sometimes very, very useful is the ability to be able to isolate lights on a per pass basis. So what we'll do is use contribution maps to actually set up all the lighting and all the reflections for the red light, and then a separate contribution to do the same thing for the blue light. So let's take a look inside our Passes tab, and let's create the passes that we need. So in our case, we can set up as many of these passes as we want. So let's say maybe the beauty pass, and we'll go ahead and set up a diffuse pass as well as a let's do a reflection and a specular pass. Alright, and let's give this a prefix. Let's say something like red light, since this will be the passes that are going to hold the red lighting information. So let's create that, and there's our passes. And we'll do the same for this blue light. And create and close. Okay, so we have those passes made. Now let's make our contribution maps for the appropriate objects. So let's take all the objects as well as just the blue light, and we'll make a new contribution map out of those. So here's our pass contribution map, and we'll create a contribution map and add the selected objects. We'll call this something like our blue light map, and then we'll do the same. We'll deselect the blue light, select our red light, right click, pass contribution map, create contribution map, and add selected. Okay, so that's our red light map. Alright, so you can tell that looking at this, you can actually have objects assigned to multiple contribution maps at the same time, which is what we have right now for the environment. So everything in the environment is actually part of two different contribution maps. So let's go back to the render settings, and let's take the different contribution maps, or the different passes, we'll associate them to this master layer. And now we'll go back to this blue light map, and we'll select all of these different guys that have the blue light, add that. Do the same for the red light contribution map. Let's select all these different passes, associate those, and now we should be ready to render. So let's go back to the Common tab, and we'll put this underneath the contribution map renders, and I'll make a new folder for the render passes. So let's go back to render and see what we get. Alright, so now the render is complete. So if we take a look at what we have rendered out now, if we take a look inside the contribution map renders folder that I've just set up, here's our different passes. And again, as I mentioned before, all these passes do correspond to an appropriate pass that we had set up here. So now, take a look at that. You can see that now, for this contribution map, this has now been isolated to just this particular blue light. So in our case, we're looking at the beauty pass for the blue light. Here's what the diffuse pass looks like, and the reflection, and the specular. All right, now this is the total beauty pass of everything that was rendered out, so this is the master beauty. And again, if we take a look at the red light beauty pass, this is what we have. And then isolated for the diffuse pass, the reflection, and the specular. Alright, so very, very useful feature as far as being able to now isolate all your different lighting, and now being able to adjust the actual lighting and kind of tweak some of these different components as far as the actual lighting goes on a per pass basis. So again, you can start to see how you can use combinations of this light contribution map and a object-centric contribution map. Right? Now, one thing that is very, very important to mention is that when it comes to these light-centric contribution maps, really this is only applicable to the Maya materials. Okay, one of the limitations right now with the mental ray materials that actually support this pass-based rendering, if I take a look inside the Hypershade, really the one mental ray material that is actually applicable to this is the MIA Material X passes, right? And one of the limitations currently, as of Maya 2009, is that this particular shader does not support this light-centric contribution map. So even if I had just this red light assigned to the contribution map and rendered this out with mental ray materials, we would still get both lights involved in the actual lighting. So currently, just a minor limitation as far as the mental ray material goes, but you can still utilize this with the Maya materials. Alright, in this lesson we're going to take a look at some of the advanced attributes that can be found on these render passes. Alright, so here's a quick look at the scene that we're going to be working with. So this is a little bit different from what we've been using up to this point. So this particular scene actually has this torus that is sort of a glass type material, so it's got a little bit of refraction, a little bit of reflection as well. And then also we have this sphere which has a transparency map that's been applied to it. And what this will do is give us a good opportunity to see some of the different attributes that are available to these render passes. Alright, now I've got 3 different contribution maps set up right now in my scene. One is for this ball, the second is for the environment, and then the third is for this torus that we have isolated. Alright, so with those, let's go ahead and add 3 different render passes. So let's add something with like a ball prefix. We'll add just a beauty pass. This will be an easy one to demonstrate. Make another one for the torus. Create that. So there's our torus beauty pass. And then we'll make a third one for the environment. And create and close. Alright, so let's take all 3 of these. We'll associate these to this particular render layer. And now let's assign them to their particular contribution map. So we'll take this ball beauty, put it to the ball contribution map, take the environment, put that to the environment contribution map, and do the same for the torus. Alright, so once those have been assigned, now we can take a look at the different attributes that are going to be controlled through these different little checkboxes. Now depending on which particular pass you have selected, you may see a different set of checkboxes. If you are using the beauty pass versus if you have the attributes for the specular pass pulled up, for example. But a lot of these are going to be very similar. So the render that we'll take right now is going to be just using all these default settings of transparency, holdout, all these different options. So just for comparison's sake, let's begin by just taking a render at what we have right now with all these default settings on all these different beauty passes. Right, so let's go ahead and render this out. This will be put into a folder called passes and then the pass name. So let's take a quick render of this and see what we get back. Alright, so now our images have been rendered out. Now before we take a look at those, there are just a couple of different settings that I do want to point out that can be found on these render passes. So the first, which can be found up here, is actually the pass name. So if we wanted to rename any of our passes, that can very quickly and easily be done from this render pass name. Now below that, we have the option to determine whether or not this particular pass is going to be renderable. So let's say maybe we have everything set and maybe we just want to re-render one particular pass. We can go in and just turn off the renderable checkbox for these other 2 passes, and then at render time, this will be the only pass that is actually going to be rendered out. Now below that, we have the pass type, which if we pull this down, this is what determines whether or not this is going to be a beauty pass, custom pass, and so on and so forth. So if we create a particular pass and then we decide that maybe the pass type was incorrect, maybe instead of a beauty pass we really needed something like a diffuse pass. That can very easily be done here rather than actually going in and making a whole new pass. Now below that we have the number of channels. Now this is referring to the number of color channels. So in our case right now we have this set to 4 color channels. So red, green, blue, and alpha. So this is going to be if you want to have an alpha channel, and then 3 channel color would be just red, green, and blue. And from here we can also choose whether the frame buffer type is going to be an 8-bit image, a 16-bit image, or a full 32-bit floating point image. Right? And again, depending on what needs you're going to be using this for, a lot of times you might find that an 8-bit image works fine, but if you really want to gain a high level of control over the image itself, you can use a 32-bit image. And then finally, just below that, we have the pass group name. Now, this is something that is automatically determined based on the type of pass that we're using. So a beauty pass, a lot of times will have the pass group name called beauties. If we were using something like a diffuse pass or an irradiance pass, it would a lot of times have the pass group name called illumination, and so on and so forth. Now what we can actually do is feed this pass group name or the pass type into our render tokens. So if we wanted all of our passes with the name beauties to be grouped together, we can insert that with this render pass file group, or this render pass file group. Now just below that, if we also wanted to feed in this render pass type, that could be done here as well. Alright, so once we have all this stuff rendered out, we can take a look at this. So here is our different passes that we just rendered out a moment ago. So here is the ball beauty pass. Right, here's the environment beauty, and again you can see that everything is black where these objects were supposed to be. This is what is being controlled by this holdout checkbox. Now this holdout makes it really, really easy for compositing to be able to assemble these images back together. We'll see that here in just a moment. So here's the master beauty, and then here is the beauty for this torus. Now if you look at this, you'll see that the torus is really not looking at all like it should. Right? So what we need to do is in this particular pass, if we go back to the torus, we need to make sure that anytime we use any reflective or refractive objects that are isolated into their own contribution map, we need to make sure that the hidden geometries are visible in the reflections and in the refractions. Right? So that's the problem that we're having right now, is that when we look at this torus, the torus is isolated on its own particular pass. And so right now it's not getting any shading information from these other objects that are not included in the pass. And really that's a bad thing for anything that's going to be reflective and shiny or has any kind of refractive capabilities. So by turning on this hidden geometries visible in reflections and refractions, that should fix that for us. So if we want, we can actually re-render that. So let's just turn off the renderable checkbox for these other two passes, and then re-render. Alright, so now our render is complete, and if we take a look at this torus beauty pass that's been rendered out, now we can actually see the reflections and the refractions of the hidden environment in this torus. Alright, so let's talk for a moment about these holdouts and how they can really be useful. So I'm going to take a second to open up Photoshop here. Now let's take some of these different passes that we have rendered out, and let's look at how easy this holdout makes it to actually recomposite this image back together. So let's go ahead and just maybe zoom this out a little bit. And let's take this beauty pass. I'll copy this and then paste that in. Now with this holdout, what this gives us the ability to do is just very simply take our layers and then just set this to either an additive or a screen mode, either one of which will kill out all the black information, and now we have a very simple composite. Do the same with our other layer. Again, just switch this to maybe an additive mode, and then there we go. We can very quickly and easily composite this back together. It saves us the trouble of having to use alpha channels and mattes and masks and these different overlay modes, and really with these particular holdouts, the layer ordering really doesn't even matter because there's just black information in the areas where we need these other objects. right? So it really makes this compositing process much, much easier when we use these holdouts. Now, again, this is an option that can be turned off if you prefer not to use the holdout. So let's go ahead and turn this renderable option back on. You'll probably notice that when you turn the renderable option off, you really don't see that much of a change in your overall render time. Again, because it is just writing out one image and then outputting these different buffers. So again, you probably won't see just a huge change in your render time. So if we want, we can always go back to something like this environment pass, and let's disable its ability to have a holdout. Alright, and let's see what we get. Alright, and now you can see that this environment beauty pass no longer has any kind of a holdout contained within it. Alright, so again, it is a very, very useful option to have this holdout, but if for whatever reason you don't want to have it there, you can always turn that feature off. Right, now a couple of extra interesting options that we do have down here is the ability for hidden geometries to either produce reflections or to produce refractions. Now what this is, it's a little bit different than the checkboxes that we looked at just a moment ago when we turned on the torus's ability to reflect and refract the environment within itself. This is really kind of a reversal of that, where now in this environment we can choose to have the torus actually leave its refractive capabilities or its refractive result in this environment pass. So for example, let me go ahead and turn off the produce reflections option, and let's turn on the produce refractions option for this environment pass. Right, and let's take a quick comparison of this. Alright, and now if you take a look at the environment beauty pass, we can now see the refractive result of this particular torus, but you'll notice that we don't have any of the reflective contribution contained within this. So this could actually be something really useful if you know you're going to have to do some kind of color correcting on this background environment, and you want to be able to have that same color correction show through in the refractive properties of this particular object. Well, that's now very easy to do. So now any color corrections that you make will be fed through this transparency and then look very, very natural at compositing time. Right, so that's a look at some of these different render flags that we have available on these different passes. Alright, in this lesson we're going to start talking about the use of these render passes together with mental ray materials. Alright, so here's a quick look at the scene that we're going to be working with. So in this case I have just this very simple scene setup, and this torus that I have right in the middle is kind of a glass type material, and this is actually using one of the new mental ray architectural pass materials, and this is one of the new materials that is actually compatible now with the render pass system. Now with these mental ray materials there are some things that we do need to take into account. Number one, there are actually very few mental ray materials that can take advantage of this render pass system, whereas almost all of the Maya nodes are actually able to take full advantage of this. So up to this point we've been using all the Maya nodes. Alright, now when it comes to using the mental ray nodes, like I said, there are just a very few that are compatible, and those are the ones that have this passes suffix at the end of them. So within Maya 2009 we have the Car Paint X passes, we have the Metallic Paint X passes, we have the MIA Material X passes, and then we also have the Fast Skin Shader passes. Alright, so at the moment, right now, I'm using the MIA Material X passes as the main material for my torus. Now, within these particular materials, there are still actually a few limitations as far as which of these frame buffers can actually be written to with these current mental ray materials. So right now I've kind of worked up a list of the actual materials that are compatible with particular passes. So for example, if you're going to be using the MIA Material X passes, these are the different buffers that we can actually utilize with this particular material. So we can use a beauty pass, we can use diffuse, diffuse irradiance, indirect, reflection, refraction, specular, and translucence. All right, these are the different frame buffers that can be output by this material. And I've also listed out the same for the X paint passes and the fast skin shader passes. Alright, so I'll include this text document with the project files for this training if you ever need to refer back to this. So let's take a look at actually outputting some of these different passes, and we'll still see a few limitations that we'll have to address here in just a moment. So let's use a beauty pass just so we can kind of have something for comparison. With this we can output a diffuse pass, we can do a direct irradiance pass, we can do an indirect pass, we can do reflection and refraction and specular. And we can also do translucence, but we don't have anything that's translucent in our scene, so no need to worry about that. We'll create that. And now let's take all these passes and associate this to this current render layer. Alright, now I don't have any contribution map set up, so no need to go through any of this extra step. Now, whenever I render, when we get our results back, we are going to see a little bit of an anomaly. So let's batch render this out, and let's take a look at the images that come back. Alright, now once these images render out, we can take a look at the different passes that have been output. So here's our diffuse pass, we have our direct irradiance, our indirect, here's our master beauty, reflection, refraction, specular, and just the overall beauty pass. Now when you look at this, you can notice that there is actually a little bit of an anomaly, and specifically it has to do with the shadow on this torus. If you look at the master beauty pass, which is basically the image that we would get back at render time if we were to just take a look at this inside this actual render window. Right, if I take a look at this, let's actually get this back up, you can see that in these different render buffers, there's actually no shadow on the areas where this torus is interacting with this particular object. But you can see that there is a shadow on this little sphere down here. Now, this is a problem that arises whenever you're using this mental ray material, or any of these mental ray materials, together with Maya materials, which is the situation that we have here. The sphere and the wall are both made up of Maya materials, whereas this torus is made up of a mental ray architectural material. And this is where we get this problem specifically with the shadows. So to get around this problem, what we need to do is make sure that if we're using one of these mental ray materials, that all of the materials and all the objects that it interacts with as far as shadows are concerned, we need to make sure that those are also using these mental ray materials. Alright, so let's close this down, and let's add in a couple of these extra MIA material pass shaders. Alright, so let's take this one, and we'll take its reflectivity all the way down, and this one we'll use this kind of as the background. So let's take this crater color, connect this in. Alright, and we'll connect this up to the background. And then we'll do the same for another MIX material. Again, take the reflectivity, drop this all the way down. Alright, and let's take this and put it onto this sphere. Alright, so now we should have a scene where we're using all MIA architectural materials, these new MIA passes. So now let's re-render and take a look at our result. Alright, and now when I take a look at the render buffers, you can see everything is now behaving correctly. So here's the diffuse, here's the direct irradiance. Now you can see the shadows are now properly contained in these different buffers. Alright, so anytime you're rendering out and you find yourself in a situation where these shadows really don't seem like they're behaving correctly, probably the first thing you should do is check to make sure that all the materials in your scene are made up of this MIX passes material. Alright, so that's a look at some of these things that we definitely need to be aware of whenever using these mental ray materials together with the pass rendering system. In this lesson, we're going to take a look at the procedure for using mental ray pass materials together with photon-based global illumination, or caustics. Alright, so in this scene I have pretty much the exact same setup that we had in our previous scene. We have this MIX passes material, alright, and this is sort of a refractive glass object, similar to what we had in the previous lesson, except now I actually have a light that's actually casting these caustic photons into the scene. And what we want to be able to get is some of these refractive kind of caustic patterns that should be coming through the backside of this torus onto the wall. Now, if you're using this MIA-X passes material, you will notice that there are some issues whenever using this together with photon-based caustics or global illumination. So one of the things that we'll notice is that as soon as we try to render this out, we'll probably be presented with this particular error that is basically telling us that no photons are being stored. All right, and this is right now a problem with the MIA-X passes material in Maya 2009. All right, so let's go ahead and just cancel out of this render. We'll stop this. All right, so our workaround for this is really a pretty simple one. What we need to do in order to get around this is we need to take this MIA-X material, and let's expand it so that we can take a look at its shading group. Now, if we double-click on the shading group, you can see that with these mental ray materials, we have a duplicate, or basically we have this same material that's plugged into the ports for the shadow and for the photon shader. Right? You can see that is the same material. Now, in order to alleviate this photon problem, what we need to do is take another material and connect it into this photon shader port, and then everything should work correctly. So the material that we can use is just one of these old MIA-X materials, not the passes one, but one of the old MIA-X materials. And now we can come in and just try to set this at settings that are pretty similar to what we had in the actual shader itself. So for this MIA-X passes, or this MIA-X material, this will be strictly used for the caustics. So in our case, we'll take the color down to 1. Looks like the diffuse weight's down at 0. We're just trying to match these two up as close as possible, so that way the caustics match what should be coming out of the material. Alright, everything looks relatively close. At 1.5 for the refraction. Alright, so now we can take this MIA-X, connect this into the photon shader port. There we go, you can see that new connection's been made. And now, let's see if this will render out correctly. Alright, so you can see we didn't get any more errors as far as the error of the photons, so that's good. But if you take a look at the render that we get back, you can see that there still is no refractive caustic capability. And if I take a look at the photon shader itself, looks like I actually forgot to increase the transparency. So that way the caustics can actually travel all the way through. Right, so let's see what that does for us. Alright, so here's the render that comes back, and you can see still really no photons have been calculated on this particular material or on this backdrop. Now this is a problem that is similar to what we had before with the MIA material. As far as the photons go, we need to also connect a new photon material to any objects that are receiving photons, so that way they can actually display the photons that are landing on them. So let's clear this out. Let's take this MIA material X. Again, let's take a look at its shading group, and we'll take a new MIA material X, one of the old materials. And just like before, let's take the reflectivity, drop this down, adjust its color accordingly, and then we'll take this, connect it into the photon shader port. And this is going to be for this background material. Right, so let's see what that does for us. Alright, so here's the render that we get back, and still no caustics, and I think it's probably because I actually forgot to turn on the appropriate shader on my MIA material, the one that's actually responsible for the caustics on this particular torus. If I take a look at the advanced refraction, one thing that we need to make sure on these materials is that instead of using a transparent shadow, that it's set to use refractive caustics instead. Alright, so that should now give us the result that we want. Alright, and now you can see that we have our caustic patterns that appear properly with this MIA-X passes material. Alright, and right now this is a known limitation with Maya 2009, But right now it is a fairly straightforward process as far as being able to fix this. We just need to make sure that the objects that are actually casting photons have some kind of an MIAX material that is applied to them, and you need to make sure that it is set to be using refractive caustics. And then we also need to take any objects that are having caustics cast upon them and then plug in a MIX material for that particular shader as well. Alright, now once we have all this plugged in, we should be able to write all this data out correctly to our different render passes. So let's go to Render and batch render this out. Alright, and now if we take a look at the buffers that have been written out, we have the diffuse pass. Again, still has the correct shadows because we're using entirely mental ray materials in this scene. Here's the direct irradiance, which is basically the direct lighting information. Here's the indirect light, so all the indirect light, including final gather, and in our case, now the caustics, are correctly contained in this indirect lighting pass, as well as if you take a look at the master beauty pass, what the entire composited image should look like. Alright, so that's a look at some of the things that we need to be aware of whenever using photons together with this MIA passes material. Alright, in this lesson we're going to talk about how we can render our various passes out into a single multi-channel EXR file. Alright, so here is the scene file that we're going to be working with. Pretty much the same scene file that we were using in our previous lesson. Now up to this point we've been rendering out our different render passes out into individual files, similar to what we see here. Right, so we have an actual file for each particular frame buffer that gets written out. Now what we can do is utilize something called an EXR file. Now this is a special type of file format that can actually hold a lot more information than just simple red, green, blue, and alpha information. We can actually write our entire frame buffer stack out into a single multi-channel EXR file. And in Maya, this is actually a very straightforward process. All we need to do is first select what kind of a file format we want. So let's choose an OpenEXR. Now you'll notice as soon as we choose an OpenEXR, Maya will automatically realize that this is the type of file format that we're using, and it will change the file name accordingly. You'll notice no longer does it have the actual frame buffers as a token, like what we had before. Alright, so it realizes that this is an image that it can write all this data out into. So let's try to switch this back. There we go. Alright, and we'll call this something like multi-channel. Alright, so really it's just that straightforward. We just choose the OpenEXR format, choose a file name, and now whenever we batch render, it'll take all of our different frame buffers, all of our different render passes, and put them into a separate channel of this EXR file. Alright, so let's take this and batch render. Alright, and you can see that the image we get back is just one single EXR file, and within this is contained all of our different buffers. Now, there are actually just a handful of programs that can actually properly open and read a multi-channel EXR file. One of those being Autodesk Toxic can actually read this right in. Also, if you're using something like Nuke or Fusion, you should be able to use this as well. And I believe also After Effects and Photoshop, we can read these with the use of a third-party plugin. So let's take a look at this EXR file inside of Toxic. Alright, you can see here's our multi-channel EXR file, and here's the actual output that we see. Now right now we're seeing the result of all of the different channels of this EXR file. Now if we select this and take a look at the options, we can choose which channel we're actually going to view from this EXR file. So if you take a look, we actually have a diffuse channel, a direct irradiance channel, indirect, and so on and so forth. So this is the indirect, or rather the diffuse channel. Here's the direct irradiance channel, the reflection channel, right, refraction, the indirect, and so on and so forth. And the beauty of this is all contained actually in one image. Alright, So with this, we actually do have the capability now, if we want to do color correction, we could just extract one particular channel, do the color correction on it, and then pipe it back into the overall network. Alright, so lots and lots of power and flexibility with these multi-channel EXR files. No longer do we have to keep track of multiple render passes within our image directory. We can just write out one single individual file that contains all the passes that we need buried within it. Alright, so that's a look at how we can render out these multi-channel EXR files and then actually bring those into an application like Toxic for compositing purposes. In this lesson, we're going to take a look at how we can control frame buffer contribution on a per material basis. Alright, so in this scene I have a situation where I actually have a material on this sphere that is being driven by another material. So in this case, if I were to actually take this light and move this around, you can see that the material that I have on this sphere is actually changing according to the light position. Right? And this is due to a material shader that I have set up. So you can see the light position is actually driving where this little brown hazy spot on this little sphere shows up. And this could be, maybe something indicative of a weather system on a planet, or maybe dust on a particular object based on the light source. But in this case, this really does kind of present us with a unique situation when it comes to using our frame buffers. And this has to do with the way that I have this particular shading network set up. So if I take a look inside my Lambert material and take a look at the shaders for this, let me actually go ahead and try to give myself a little bit more room to work here. Now if you look, I actually have a shader that's a little bit further back in my shading network that's driving this final result. So in my case, I'm using the out color of this red channel, so using basically the brightness information to control the offset of this ramp. Alright, so basically we're just looking at brightness information and then using that to drive the ramp that also has this particular color plugged into it. Right, so that's how we get this little brown hazy spot that's actually able to change. Right, so this is a look at the actual ramp itself. We have this blue material further down, and then in this port we have this brown sort of fractal material plugged in. Now where we're going to run into a problem with this is the fact that I actually have a material that's further down in my shading network that's driving the result that we get further up. And the problem is that when it comes to rendering out the frame buffers, we're going to run into a situation where this material is actually contributing in some way to the frame buffers themselves. Alright, so we take just a quick render. You should see that the render itself looks perfectly fine. But if we go up to the passes, you can see right now I have 3 different passes that are associated with this particular render layer. One is the diffuse, which is basically just lighting and shading information. In other words, we should get something very similar to what we see here. We also have the diffuse material color, which is flat shading. So it'll try to look at just the flat, pure color of this without any of the additional shading contribution from the light itself. And then we have the direct irradiance, which is really the exact opposite. It's all the direct light shading information without any actual texture or material color on here. Now, all 3 of these are going to have issues when it comes to using render layers together with this particular shading network that I have set up. So to illustrate this, let's do a quick batch render. Alright, now if you take a look at my render buffers that come out, you can see that they really look nothing like the render that we had in the viewport. So this is the result of the diffuse. This is the diffuse material color, which should be just the pure material color without any lighting or shading information, and the direct irradiance, which should be all the lighting and shading information with no material color. And you can see all 3 of these are very blown out compared to what we should be getting with the beauty pass. Alright, so this is a situation where it becomes really, really essential to be able to control the frame buffer contribution on a per material basis. And again, this is because the frame buffers that we are currently using, what they do is basically evaluate the result at the end of the shading network. And in our case, we actually have a material further down in the shading network that can contribute to whatever frame buffer information's been written out. So if we take a look at the material, we can actually disable its frame buffer contribution. So let's take a look inside the mental ray tab, and within that we should have frame buffer contribution. All right, so right now the write operation is set to add, so let's set this to no operation. And now let's batch render this out. Alright, so here's the result that we have now with the diffuse material, or the diffuse pass. You can see it's still fairly blown out. And if we take a look at the diffuse material color, now this looks correct. This is really closer to what we should be getting. If you go back to the direct irradiance, this is still fairly blown out as well. Now the reason that this is happening is because this is really more of a cumulative effect. It's instead of just taking the shading information at the end of the network, which it should be, it's also mixing in this color as well. And what that gives us with the frame buffer is this mixed, very blown out result. Alright, so that's why we're trying to disable this particular material's frame buffer contribution, so that way we don't get any of this extra contribution that we really shouldn't be getting. So rather than no operation, let's try setting this to multiply. Now what that should do is kill out any of this white, bright information when it comes to writing out the information into the frame buffer. So let's do a batch render. Alright, and now when we look at the diffuse map, you can see now everything looks just as it should. So here's the diffuse. Here's the diffuse material color, which again now looks just like it should. And we have the direct irradiance, which now again looks just as it should. So this becomes something very, very important to be able to control as far as adjusting on a per shader basis its ability to write data into the render buffers. All right, and again, whenever using shaders further down in the network to drive your result further up ahead, this may be something that you have to use quite regularly. All right, so that's a look at how we can control this individual frame buffer contribution on a per material basis. Alright, in this lesson we're going to take a look at how we can build our own custom frame buffers to output data from any point along our shading network. Alright, so in this scene I have just a very simple object set up, and in this object I have a shader that's set up to modulate itself between two different materials depending on light intensity and light direction. So with this I actually have two separate materials. You can see they're two very distinct materials that are able to blend together. Now there may be a situation where I would like to actually take this and rather than just render this image out, maybe I'd actually like to be able to split this image apart into these different materials in case I needed to come back and be able to do color correction on one without affecting the other. Now, right now, if we were to use any of the render passes that we've been utilizing up to this point, we really would not be able to use those for this particular purpose because these actual render passes will evaluate whatever is at the end of your shading network. Alright? So in this case, what we can actually do though is create our own custom frame buffers that can intercept the data at any point along the shading network and then write that out into its own buffer or its own image. Alright? So the process of doing this is really pretty straightforward. What we need to do is take a look inside the mental ray nodes, and we'll scroll all the way down to the bottom and take a look under miscellaneous. Alright, so you should see now, starting in Maya 2009, a few extra nodes down here. So we have write to color, write to depth, write to label, and write to vector buffers. So in our case, we're going to use the write to color buffers. And what we'll do is make our own custom buffer for each of these different materials that we want to be able to write out. So let's take this custom frame buffer, or this write to color buffer 1, and we'll call this something like blue Lambert buffer, just so we can tell what this node is actually connected to. So in this case, now we could just take this blue Lambert, connect it into the color input, and now this buffer knows what information to write out. The thing that we need to now consider, though, is it needs now a custom color pass in order to write this information to when it comes to writing this information onto a disk. Now, right now, we do not have any custom color passes that have been defined. We have to define those back here in the render setup. So let's add a new custom color. There we go. And we'll call this something like Blue Lambert. There we go. Create and close. And now let's associate this to this particular render layer. And now, whenever I go back to this Blue Lambert frame buffer, I should be able to pull that down and choose this custom color render pass that I just built. Now, I'm going to do the same thing for this orange blend up here as well. So I'll make a new custom color buffer. Give this its own new name. Alright. Again, we'll take this orange blend, drop it into the input of this buffer, and then we'll give it a new pass as well. So new custom color. Create and close. Connect that. Alright, so now that's been associated, this orange blend. And now in this custom frame buffer, I'll choose that as the image to write out to. Alright, so now we have two custom color buffers, and we've defined the actual image file that it's going to write out to. Now we have one last thing to do, and that is this will write out the two separate images for these particular shaders. But one thing we're not going to get is the blending or the masking information of how these two are actually blending together on this particular material. So what we can do is actually use these frame buffers to write out a completely separate bit of information from what we have here. Alright, so let's take this ramp shader. Let's just kind of move this over. I'll add in a new write to color. We'll call this something like ramp buffer. Okay, now again, we'll plug this into the input so that knows what to actually evaluate. But what we can do with this custom frame buffer is tell it once it actually hits something that is plugged into this input, it can actually evaluate another shader and then write that out into the frame buffer instead of whatever we have plugged into the input. So let's take this ramp shader, and I'll just press Control D to duplicate it. And I'll take one of these different nodes, and I'll make this completely white. So now we should have now just a black and white version of whatever this particular shader is. And this I'll plug into the evaluation. Or rather, I actually have these backwards. I want the evaluation to happen on this particular node, this ramp shader, but I want the input to be this ramp shader. In other words, the information that is going to be written out goes into the input, and it'll evaluate this shader. Okay? So now, let's make our own custom color for this. Create and close. Associate that. And now connect that into our custom ramp buffer. Alright, so now we have three different buffers set up to write out the information at three different points along this shading network. So now all that's left to do is just render this out. So we'll go to batch render. And now if we wait for the render to happen, we should now see these different buffers that have been written out. So here's the Blue Lambert custom buffer that was written out. Here's the Beauty Pass. Here's the Orange Blend buffer. And then here is that black and white version of the ramp shader that's been written out. And this can be used as our mask to blend between these other two materials. Alright, and if you take a look at my Photoshop composition, that I've put together just really quickly, you can see that's exactly now the effect that we get. So this is the composited result of this orange blend and this blue Lambert, and this black and white ramp image is being used as a mask for this orange blend. So now I do have the added control now of being able to come in and do color correction on a per layer basis. So I can come in, brighten up anything I need or darken it, change the colors as I see fit, and not have to worry about affecting anything else on the material itself that I don't want to. Alright, so that's a look at how we can get some very, very useful results out of these custom color frame buffers. Alright, in this lesson we'll take a look at how the older Mental Ray architectural materials can be made compatible with the Render Passes system. Alright, so this is the scene that we have and the scene that we're going to be working with. Now in this particular situation I have a scene very similar to what we were working with earlier, where we have this torus that is using a Mental Ray architectural material, except this torus is actually using the older MIA-X material. Right? It's not using the pass-based material. So if this is a scene that was maybe built in an earlier version of Maya, and now you want to be able to use this together with the Render Pass system, there are a few different ways that we can go about doing this. Number one is if we take a look at the MIA-X material, and if we take a look a little bit further down toward the bottom, we should have a little tab down here called Upgrade Shader. And so once that's expanded, we can click on this Upgrade to MIA-X Passes, and what this will basically do is add the appropriate nodes to this particular material to make it compatible now with the Render Passes. And the beauty of this is that it won't necessarily go in and adjust any of these settings that we've already got set up. So our color, our transparency, refraction, all of these things will remain the same. Alright, so that is one method that we have to be able to come in and make this material compatible with the Render Pass system. Now the other method that we have, if for whatever reason you are maybe not able or would prefer not to upgrade this material, what we can do is actually use the render buffers or the custom buffers to output the different areas or the different components of this material. Alright, so let's get a little bit of space here to work. Alright, so here's our MIA material. Now let's scroll down and we'll use a few right to color buffer nodes, and we'll use these to capture the different areas that we need. So we'll use one to capture reflection, we'll use one to capture refraction, one to capture diffuse color, and let's say one to capture specular color. Alright, so let's call this something like spec buffer. Right, so that'll be my specular component. We'll call this diffuse buffer. Alright, just so we can really kind of keep these straight. And we'll call this reflect buffer. And refract buffer. Okay, so now we have these actually set up. Oops, let's go back to my Hypershade here. Now, just to give myself a little bit more room to work, those should be all the nodes that I need. So now, let's come in and connect in the appropriate components. So let's just middle click, drag this over. We'll connect this to Other. So in this MIA material, we have underneath the outputs, down toward the bottom, we have these different parameters. Let's see if we can find those. Those are going to be right down here. So we have diffuse result. So this diffuse result, for the spec buffer, we actually want to try to grab the specular result, and we'll plug this into the color. Alright, so now this particular buffer should be writing out in its color information the specular result of this particular shader. So we'll do the same for the diffuse. Connect it into Other. And let's look for the diffuse result. There we go. Connect that into color. And we'll do the same for these other ones. We'll connect in reflect and refract. Okay, so here is our reflect result. Let's see if we can find that. There we go. Connect that into color. And finally, refract. So here's our refraction result into the color. Alright, so now we have these different buffers set up. Now we need to make custom buffers to be able to write this information out to. So in our case, let's make our different buffers for this. So we'll make our custom color, make one for specular, one for diffuse, one for reflect, and one for refract. Alright, very nice. So we'll take these, associate these to this particular pass, and if we need to be able to capture information from the rest of our environment, we can do the same. So for this one, we can just use our normal material since we are not necessarily trying to capture anything out of the ordinary. So we can use our diffuse and go ahead and get indirect. And while we're at it, we can go ahead and, actually I don't think we'll need anything else, since really there's nothing else that's going to be reflective or refractive on anything else in the scene. So let's go ahead and create and close, add those, and now let's render everything out. Actually, before I render these out, one thing that I do need to do, getting a little bit ahead of myself, is I need to make sure that these buffers are actually connected to some kind of a buffer in the actual render settings. So in the refract buffer, we'll connect these up to the correct buffers. So the reflect, we'll connect this one up to diffuse, and connect this one into specular. Alright, now we should be able to render this out and see our result. So let's go to batch render. Alright, so now if we take a look at the images that have been rendered out, if we were to take a look at something like the specular custom color, there we go, there's a specular information. Here's our refraction color information that's been written out, and reflection information, and so on and so forth. Alright, so that is a look at a couple of different ways that we can go about using these older MIX materials in a way that is compatible with this new render pass system, either by making our own custom buffers to output any information we need from this shader, or by just simply upgrading this shader to the MIX material passes. In this lesson, we're going to take a look at how we can use the fast subsurface shader together with the new render pass system. Alright, so in this scene we have just a very simple object, and you can see right now there is a little bit of subsurface shading that's been applied to this. So we have a little bit of a backscattering effect of light coming through from the backside. It kind of scatters through to the front. And then down here we have a little bit less of a subsurface scattering result. Alright, now when it comes to actually using this fast subsurface shader together with the passes, you can see that right now this actual fast shader, the passes that it's able to output right now are somewhat limited. We have just beauty, diffuse, direct irradiance, and specular. Alright, so let's take a look at some of the different passes that we can output. So up here, let's go ahead and add in our passes. Alright, so we've got our beauty. Let's add in a diffuse. We'll add a direct irradiance. And really we don't have specular on this particular shader, so we really don't even need to add a specular at this point. So let's go ahead and associate these. And let's render our result and see what we get. Alright, so here's our direct irradiance. Right, this is the master beauty. This is just the regular beauty. And right now we don't have anything in the overall diffuse. Alright, so that's really about it as far as actually writing out information from this fast subsurface shader when it comes to actually using these pre-built actual render passes. But what we can do is similar to what we've been doing for the past couple of lessons. We can actually use some custom frame buffers to extract the information that we need from this particular shader. Alright, so let's go ahead and try to give myself a little bit more room to work here. Now let's go to the mental ray nodes, and just like what we've done before, we'll drop in a couple of these custom frame buffers. So let's maybe add in 3 of these. One for the front scatter, one for the back scatter, and then one for the diffuse weight, or the diffuse result. Alright. So let's call this something like the back buffer. This one could be the front buffer for the front scattering information. And then this one can be the diffuse color. Alright, so let's connect these up and make the connections. So for this fast skin shader, again, this is going to be going into the back buffer. So what we want to look for is it's going to be found right down here. It's going to be the back result is what we're looking for. There we go. We'll take back result and plug it into the color. And we'll do the same for this one. This is going to be the front buffer, so we're going to look for the front result, plug that into the color, and then finally do the same for the diffuse. Alright, we'll try to take the diffuse result and map that into the color. Alright, now just like what we had to do before, now we need to make our custom buffers for this. So we'll use a custom color. Give this some kind of a prefix. We'll make this the front color buffer. Make this one the back color buffer. And finally the diffuse. We'll associate those in. And now let's map these to the correct output. So back buffer, map that to the back. Front buffer, we'll map this one to the front. And diffuse, connect it into the diffuse custom color. Alright, now let's render and see what we get. Alright, so here's the results of the images that have been output. So if we take a look at, let's say, the back custom color, there we go. There's all the back scattering information that's now been written out to its own buffer. Diffuse, doesn't look like we have much in the diffuse, probably because we don't have a very high diffuse weight set. Although if you look, there's a very, very, very slight rim of light right back here, so it's very, very subtle as far as the diffuse result goes. Here's the front custom color, again, been written out to its own custom buffer. So immediately you can start to see how these different buffers can start to become very, very useful as far as being able to write out information that we may not normally be able to get from these pre-built render passes. So over the course of the past few lessons, we've seen lots of different results for being able to utilize these buffers to get the information that we need out of these particular shaders. Alright, so that's a look at how we can use these custom buffers to get front and back scattering information out of our subsurface scattering shaders. Alright, in this lesson we're going to take a look at how we can output pre-compositing information from Maya over into Toxic. And that way we can use Toxic to automatically recomposite all of our different render passes into a final image. Alright, so here's the scene file that we're going to be working with. Pretty much the same file that we've used a little bit earlier in this training. So what we first need to do, just like what we've had to do up to this point, is we'll go in and define output directories and the actual file formats. So let's make something called similar to, let's say, Toxic out. Alright, that'll be the directory, and that will add in our render layers. Alright, we'll just do a single frame. And in this case, we can choose any file format that we want. Let's choose something like a Targa file, for example. Alright, well, let's actually, instead of render layer, let's make sure we do render pass. There we go, because we'll actually need a new file for each pass. So now, let's come in and just add in the passes that we need. So in our case, we're going to need to make sure that we have a ambient pass. We need a diffuse pass. There we go. And we need to make sure that we also get an indirect pass in here, so that way we can have lighting and caustics and things like that. Let's also make sure that we get a reflection pass, a refraction pass if we need to, and a specular pass. Alright, so with all those, let's create, and let's take these and associate those to this render layer. Alright, now the first step with this pre-compositing process is to just first render this data out somewhere so that it exists. So let's come in and give this just 1 second to update. There we go. And let's go to render and batch render this data out. Alright, so now our images have been rendered out. And one thing to mention is that the template that I'm going to be using to reassemble this back in Toxic is basically the default template. And so by default, the template is going to be looking for these particular passes. Alright, so if we were to add any of these other passes like direct irradiance or some of these other passes, Toxic won't necessarily know what to do with those as far as putting them together, at least not with this default template that we're going to be using. So as long as you make sure you add these, then you should be okay as far as this particular demonstration goes. Now, once we have these passes that have been rendered out, you can see they're now labeled in this Toxic Out folder. So here's our individual images. Now what we need to do is go up to this render menu and export the pre-compositing. Alright, so it's going to pull open this little window. If we expand this, you can basically see what it is that we are going to be outputting. So we have our default camera, and if we expand that, you can take a look at the different render layers that are contained within this default render layer. Now any of these we can turn off if we decide we don't want maybe this information for the pre-compositing to be output. Really, that's up to us. But you'll notice as soon as we turn any of these icons off, that these icons only become partially exposed. And so what that means is that if you do have this collapsed, you'll be able to see that something within this is actually turned off. So it kind of gives you a nice little visual reference. If that's a full circle, that means everything inside is turned on. So you can see our render layers and our render passes. Now the main thing that we need to do is define some kind of a scene anchor. Now what this name is, it really doesn't necessarily matter. It can just kind of be an arbitrary name. But this is what Toxic will use to tie all this information back to Maya. So let's call this something like Toxic Pre-Comp. Alright, again, can really be called anything you want. And now let's export all. And now it's going to ask to export this .precomp file. Now this is something that Toxic is going to refer back to. So let's make sure we save this in a proper directory. Right, and in my case I have a Toxic project set up, and we'll call this something like Pre-compositing. Again, really doesn't necessarily matter what the scene name is that we call this. We'll save this out, and now we're ready to use this inside of Toxic. Now, one thing that is going to give us a little bit of trouble with this pre-comp script is that right now it's set to use an IMG file, or a file with a .img extension on it, rather than the .tga that our files use. Now that .img would be just fine if you were going to be using some kind of an EXR file that's going to be referenced back in. But for us, we're going to have to manually go in and make some minor changes to this pre-comp script in order for this to work correctly back in Toxic with these .tga files. So this is a situation where something like Edit Plus can come in really handy. This is a free application. So let's use Edit Plus to open this up. Alright, so if you look, you can see this whole pre-comp script that gets written out. And specifically, if you take a look down toward the bottom, you can see that it's looking for images with this .img extension on it, right? Which they don't exist because instead we're using .tga files. So this is something that's very easy to fix. Just go to Search, Replace, and we'll replace anything with the string .img, and we'll replace that with the string .tga. So let's replace all. All right, very nice. Let's close this. You can see now this has been replaced. And that should now work correctly. So let's save this. Close this out. And now we can bring this into Toxic. Alright, so let's go to File, Import. Alright, and inside this Toxic project, we want to find this pre-compositing.precomp that we just saved out of Maya and just went in and edited with Edit Plus. So with this, we can right-click and go to Import. All right, now once we do this, it's going to break open this window where it's going to ask us to define a folder that it's going to create for the render layers and the render passes. We'll go ahead and just leave everything set to default, hit OK, and now it's going to go through the process of building this up. And now, once this process happens, you'll see it generates a new comp for us called Toxic Precomp. You'll notice that this corresponds to the name of the anchor that we set back in Maya. So now we can take this Toxic Precomp, open this guy up, and here we go. Here's our final render. Now what's generated here is actually a comp. So if we were to right click and open this, what we should see is all of these different passes have automatically been reassembled by Toxic. So here's the diffuse, here's the specular, indirect, and you can see how all of these different pieces get fit one right over the other. So here's ambient and diffuse, then it adds specular on top, then it adds indirect, then refraction, then reflection, and then finally any alpha channel information and final output. All right, so this becomes very, very useful, especially because we can not only do this on one particular pass or one particular layer, but if we had multiple passes set up on multiple render layers, all of this data would be brought over into Toxic and then recomposited properly. Right, so this can really save a lot of time as far as having to go in and manually recomposite all of these different pieces back together. All right, so that's a look at how we can take all this precompositing information from Maya and carry it over into Toxic for reassembling our different render passes. So this now brings us to the conclusion of our training on using render passes in Maya. So over the course of the past couple of hours, we've had a chance to talk about a lot of tools and a lot of features that are related to this new rendering system. So we've started out by exploring the concepts of the render passes and the frame buffers that they use to write out their data. So from there, we learned how we can create object-centric and light-centric contribution maps to be able to isolate lighting and objects onto individual passes. We've also seen how we can create our own custom rendering buffers to output data at really any point along the shading network, as well as seeing how Toxic can be used to automate the process of reassembling our render passes back into a final image. So now that you understand the uses of the render passes, you really should be well on your way to saving a large amount of render time while still having a very high level of control over your final image by having all of these different elements split apart into multiple passes. And to continue your education and expand your skill set, I encourage you to visit us online where you'll find the latest announcements. Built on educational values, Digital Tutors started with a simple vision in mind to help new and experienced artists become more productive by learning new software and production techniques. We've been a leading online resource for free video-based training and have been instrumental in aiding millions of artists on a daily basis. Learn more about the multitude of training solutions that we offer for various areas of the production pipeline at digitaltutors.com.